Hello guys. Alright, sorry if there's a background noise. I got my fan on and it's like really hot, outside because the heat wave, whatever. So that's why I got the background noise on. Now I'm hoping that hoping that I could get some multiple choice problems done. Alright. For all positive values of x, which expression is equivalent to x to the 3 over 4 power? Now, what you gotta know is that when you have, for example, let's say the square root, not the square root, let's say if you have x to the a and you're taking the bth root of it, this becomes x to the a over b. So, for example, if we have the square root of, let's say, 3, not the square root, the x to the third power, and let's say if we're doing the fourth root of that, this is going to turn into x to the 3 over 4 power, right? So notice how the power here goes up in the numerator, and then the root goes in the denominator. So in this case, I kind of already just did this problem, but yeah, it's going to be equal to 1, right? Mr. Fad, blah, 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 wants to conduct a survey to see how students feel about changing the school's mascot name. Which plan is the best process for gathering an appropriate sample? So, this person's statistic class, right? They want to see, how the students feel about changing the school mascot's name. And when you're doing this type of survey, right, you're in like some sort of school setting, right? You want to get basically all the students' opinions, right? So what's going to be happening is, all right, let's take a look. Survey students in a random sample of senior homerooms. The problem with answer choice number 1 is that you're only surveying the seniors, right? You're leaving everyone else behind. Survey every 10th student entering art classes. Once again, right, you're leaving a lot of students behind. You're not kind of getting everybody's opinions on this. Number 3, survey every 4th student entering the cafeteria during each lunch period. Well, this seems like kind of the answer choice where you would actually get kind of the most amount of, or most amount of sort of people, or most amount of sort of variety in your sampling process. If you survey all the members of a school's varsity sports team, once again, right, you're only limiting yourself to specific groups of people, right? You want to limit it to everyone else. So that is what's gonna be the answer, number 3. Number 3, this one you could probably just use synthetic division. So what you're gonna do is you're gonna line everything up. So you're gonna create a sort of division sign. The bottom here, notice that you have x plus 3 in the denominator. What value of x makes the denominator equal to 0? That's just gonna be x is equal to negative 3, right? So when x is equal to negative 3, our denominator is equal to 0, and on the inside you're going to put the coefficients of every term here. So every term that you have, you're going to put a coefficient there, right? So 2 goes in this spot, right, because it's 2x to the third power, then 7x to the second power, minus 3x minus 25. Now you're going to do the synthetic division. Drop down the first term, then once you drop it down, multiply it. So 2 times negative 3 is negative 6. Add them up, right? That's why I have this positive sign here. Multiply again. Add them up. Multiply again. Add them up. So the resulting answer is going to be, well, notice you have a 2 here. So this will correspond to the 2x squared term, right? Because when you're dividing 2x to the third power by an x term, you're going to get 2x to the second power, right? So your answer is always going to be 1 power below than what you started in scenarios like this, right? So you're going to have 2x squared plus, and this is going to be 1x minus 6, and then this is going to be minus 7 over x plus 3. All right. Remember that whenever you're writing out the remainder, notice how this negative 7 right over here, this is something known as the remainder. This is the remainder for our synthetic thingy. And what you do is you put the remainder up top, and then after that you put whatever you're dividing by. In this case, you're dividing by x plus 3, so then you put that on the bottom, and then you have your answer. So this looks like number 1. And a group of 40 people, 20 have brown hair, 22 have blue eyes, and 15 have brown hair, both brown hair and blue eyes. How many people have neither brown hair nor blue eyes? Okay, so for a problem like this, I like to do a sort of set diagram. So you're gonna have let's just say this set represents people with blue eyes, and let's say this set represents people with brown eyes. Now we know in total there has to be 40 people. Alright, so I'm just gonna put a 40 on the outside to represent that there has to be 40 people in total. Now it says that 15 people have both brown hair and blue eyes. So 15 both have brown hair and blue eyes. Now if there's only 20 people, if there's 20 people that have brown hair, well, the amount of people that only have brown hair is going to be 5, right? Think about it. There's 15 people that have both brown hair and blue eyes. That means that there has to be 5 people that only have brown hair, because 5 plus 15 gives you 20, the 20 people that have brown hair. Meanwhile, if 22 people have blue eyes, and you know that 15 of them have blue eyes as well, then the remaining ones has to be 7, right? The remaining amount has to be 7. Now, if you have 40 people in total, I'm just going to subtract all of these numbers. So 40 minus 5 minus all of that. This is going to be 20 minus 7. It's going to be 13. So it's going to be answer choice number 2. Consider the function defined by the graph. Which equation can be used to show the graph, to represent the graph below? Alright, so let's just pick this point right over here. This point looks like 2, and then go 1, 2, 3, 4. So this point right over here is 2, 4. Let's take a look at what's happening on this graph. Let's see. At x is equal to 2, we go 1, 2, 3, 4. So this is negative 4. Notice how, so this is 2, negative 4. Alright, now notice how that whatever x value you put in, you're going to get some positive y value for this graph, right? But notice how for the second graph, whatever x value you put in, it's going to lead to the negative of whatever you have in your y value. So essentially f of x, right, if this is, h of x, if this is your original function, h of x is your original function, well then this transformation would just be negative h of x. So whatever value that you have originally, you're just going to take the negative of that, right? So in this case, originally I had 4. Well, I'm just going to take the negative of 4, and I'm going to get the new y value for my transformed graph. Never fear, the king is here. Alright, sounds really cool. For the polynomial p of x, if p of 3 is equal to 0, alright, this one you can kind of just, alright, look, so let's say if I have something like this, x minus 3 times x plus 2 is equal to 0. Notice how if this function, let's just say this is f of x, I don't know, I'm just doing something random here. Let's just say this function right over here is f of x. Notice how when the x value is equal to 3, notice how when you plug in 3 in for x, you're going to get 3 minus 3, which is 0, and 0 times whatever this is 0. So notice how when x is equal to 3, basically, notice how when the x value is equal to 3, aka f of 3, you're going to get a y value of 0. And that just tells us that x minus 3 is a factor of it. So this is basically the factor theorem, right? If you have a function, let's just say f of x, and you find out that f of 3 is equal to 0, that means that x minus 3 has to be one of the roots, right? Because when you plug in 3 in for here, the 3 minus 3 just makes 0, and then after that you're just going to get 0 as, the thing. So in this case it would just be number 2. The solution to this equation is what? So let's just do this problem real quick. 5e to the x plus 2 is equal to 7. Now if you really do not know how to do this problem, you can always just use your graphing calculator, you check the answer, and then you see which of these answer choices are the right answer. But let's just say your calculator ran out of battery. Divide both sides by 5. 5's cancel out. You get e to the x plus 2 is equal to 7 over 5. The next step you want to do is you want to take the natural log of both sides. Alright, the natural log is basically this ln button. Whenever you're trying to solve these types of equations and you see an e right over here and it's asking you to solve it, most of the time you're just gonna have to resort to using ln. Alright, ln is what you're gonna be using, because ln and e are inverse functions, so they're gonna cancel out. So you're just gonna get the top right over here, what's remaining, which is x plus 2, and that's going to be equal to ln of 7 over 5. Now after that you could just subtract 2 from both sides, so you get x is equal to negative 2 plus ln of 7 over 5, and this looks correct. Yep. Alright, consider the system of equations below. What is the solution to the given system of linear equations? If you really kind of don't have any idea how to do this, at the end of the day, you can just guess and check this. Alright? Let's just do the guess and check method, because I'm feeling very lazy right now. Let's just say if answer choice number 1, let's just kind of see if this is correct. So when the x value is equal to 1, when the y value is equal to 1, and when the z value is equal to 2, you're going to have 1 plus 2 minus 2, that's equal to 1. Okay, so it works for the first one. If the x value here is equal to 1, the y value here is equal to 1, and the x value here is equal to 2, you're going to have negative 1 minus 3 plus 4, because 2 times 2 is 4, that is equal to 0. Alright, let's check the final one. If x value is 1, the y value is 1, and then the z value is 2, you're going to have 2 times 1, which is 2. 2 minus 4 plus 2, that's not equal to 10. Alright, so it can't be number 1. And then, you can just kind of guess and check the rest. I don't think it's answer choice number 3, because it just does not work for the first problem. Right? 2 times negative 1. Actually, it does work for the first one. Not bad. Alright, so put a 5 here. That works for the first one. Okay. Put a 5 here. Let's just see. Put a negative 1 here. This turns positive. And then you're going to have a 2 here. So this is 2 times 2. That's going to be 4. So then you're going to have negative 5 plus 3 plus 4. That's not going to be equal to 0. Alright. Alright. Let's do number 2. Let's see if this is correct. When x value is 3, y value is negative 1. So that's 2 times negative 1, which is negative 2. And the z value is 0. So that's 3 minus 2 is equal to 1. Let's check this one. When the x value is equal to 3, the y value is equal to negative 1, so this is going to turn positive, and z value is 0. Oh, this works for the second equation. Alright, let's see. Third equation. If the x value is 3, 2 times 3 is 6. If the y value is negative 1, this is going to turn positive. And when the z value is 0, 6 plus 4 is equal to 0. So number 2 is going to be our answer. Shout out to Sean Dosey. Shout out to Sean Dosey, because he got the question correct. Alright. I'm sorry guys. I'm kind of like on a crunch for time. This one you just literally just plug it into like the formula, and I don't have my calculator with me, so I'm just gonna skip that one. I'm sorry guys. For all real values of x, x minus 2. You have this. What is the value of f of x minus g of x? Okay, so you could just kind of FOIL this. Actually, there might be a creative way of doing this. All right, you have f of x, which is x minus 3 squared. And then this is going to be minus g of x. We know g of x is x plus 3 squared. This is a difference of two squares, actually. This is actually a difference of two squares. So you can actually use the difference of two squares to help you solve this problem. But because I want to guarantee that my answer is correct, I'm just going to FOIL everything, right? Because at the end of the day, this is like a 3-hour exam. So it's like you have all the time in the world. All right, so you're going to have x squared minus 6x plus 9 for this term, and this is going to be subtracted by, don't forget to put it to parentheses, right, because you're subtracting by this whole thing, right? So this is going to be x squared plus 6x plus 9. So now when you distribute the negative sign, you're going to get x squared minus 6x plus 9. That's our original term, and this is going to be minus x squared minus 6x minus 9. Minus 9's cancel out, the x squares cancel out, you're going to get a negative 12x, right? Because negative 6x minus 6x is negative 12x. And I can actually, you know what? Screw it. I'm using Desmos. Alright, you have x minus 3 squared, and then minus x plus 3 squared, negative 12x. They're the same line. Alright, so that's how you know it's correct. Alright. You have f of t, that's gonna be always trust the king. Alright. That's great. Thank you. I always trust you. Alright, f of t is equal to 50 times that statement is true half each year, or the mass of the original sample is this. What do you think this is? What do you think this is? After t years. Well, t is in years. What the hell? So, if t is in years, that means that f of 5715, that's going to be equal to 50 times 0.5 to the 5,000 blah 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 minus, so that's just going to be to the first power, right? Because 5,715 divided by that, the same thing, is equal to 1. So this is going to be equal to 25. Alright, notice how for this formula right over here, it's in the form of basically an exponential function, but essentially the initial amount multiplied by 0.5 to the time over the half-life. This is the formula, for half-life. Alright, the amount of your substance that you have over a certain period of time, that's going to be equal to the initial amount multiplied by 0.5. You can think about 0.5 as your decay rate, right? So every half-life that happens, the amount of your sample decreases by a half, right? So if you had 100 grams of a substance at first, after one half-life, you're going to have half of what you originally had, right? That's why it's called a half-life, and time over half-life. Notice how the half-life in this case is 5,715. So 5,715, this is saying the mass of carbon is decreasing by half each year. It's not each year, it's every 5,715 years, right? Because our time is in years. So yeah, number one, I don't think that's correct. The mass of original sample was 50 grams. Yeah, that is 50 grams, right? Notice how when your time is equal to 0, you have 0.5 to the 0th power, which is just equal to 1. So then you just have originally 50, right? When the time is equal to 0 years, you originally have 50, right? And it also fits with this formula, so yeah. Consider this: over the interval, average rate of change g of g and t is true. All right, average rate of change is literally just a slope. All right, so it's literally just a slope over the interval 2 and 4. So let's see, when the x value is 2, so the y value is 4, and when the x value is 4, the y value is equal to 3. So what's the slope of this line? It's going to be your change in y, right? Your change in y, so 3 minus negative 5 divided by 4 minus 2. That's just equal to 8. This is just equal to 2. So 8 divided by 2 is 4. So average rate of change for this is 4 over the interval 2 and 4. And for this function right over here, when x is equal to 2, the y value is equal to 1, 2, 3, 4. What? 1, 2, 3, 4, 5, 6. And then when the x value is 4, 1, 2, 3, 4. Gotta make sure I'm not miscounting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 minus 6 divided by 4 minus 2 is going to be your average rate of change. This is going to be 4 divided by 2, which is 2. So notice how the average rate of change for t of x is going to be twice the amount for g of x, right? So the average rate of change, or another way to say it, is that the average rate of change for g is half of what's for t. All right. Ooh. Parabola stuff. So you do actually have to know parabola stuff, and usually, like 95% of the time, the parabola is either going to be looking like this, or it's going to be looking downwards. All right. I'm pretty sure rarely do the regions give away sideways parabola, so I would not worry about the formula for sideways parabola. I would more or less worry about the formula for original parabola. A parabola is pretty much defined as the set of all points that are equidistant from a point and a line. So if I have this parabola right over here, if I have this parabola right over here, right, and let's say this is a point and this is a line, notice how for every point on this parabola, it's going to have the same distance from this point as to the line, right? It's going to have the same distance. I know this is not a very good diagram, but you kind of get the idea. The point that it's equidistant to is called the focus, and the line that's equidistant to, it's called the directrix. All right. Now a parabola has the formula y is equal to 1 over 4p times x minus h squared plus k. Okay, where h comma k is the vertex of the parabola, right? Because the parabola has vertex, and p is just the distance the vertex is from either the focus or the directrix. So I'm just gonna say focus. All right, so p is basically the value where link where do. Yeah, the other sideways formula is that, but I've rarely seen like the regions like give it out. It's always either like just like a regular parabola, quote unquote. All right. But basically, if I were to draw out this diagram, so we have directrix at y is equal to 3 and a vertex at 2 comma 1. So I'm gonna make a new diagram. All right, so it's gonna have a directrix at y is equal to 3. Y is equal to 3. And then it's gonna have a vertex at 2 comma 1. So 1, 2, and then 1. So this right over here is 2, 1. This is my vertex for the parabola. Notice how because the vertex of our parabola is below the directrix, when the shoot, I cannot like talk right now, guys. I'm like stuttering so much, but anyways, when the vertex is below the directrix, the parabola is going to be upside down. So that's just, it's unrelated to the problem we're doing right now, but it's still good to know because the regions can always test you on this. Now, notice how the distance, from 1 to 3 is 2, right? So the distance away the vertexes from the directrix is going to be a distance of 2. Now we said how for the focus of our parabola, it's also going to be the same distance, right? So if we're going 2 up for the directrix, we're going to go 2 down for the focus. So notice how you're still going to have the same x value, but your y value is going to go to -1, right? Your y value was originally 1, but if you go 2 units downwards, it's going to be -1, right? Because 1 minus 2 is -1. So that means the answer is a 2 comma -1. Your x value in this case does not change, right? Because you're going downwards. But yeah, that's pretty much it for this one. Am I skipping one? I think, yeah, there should be one here. Oh, this problem, you just use the function on your calculator, norm CDF, norm CDF, and then I don't have my TA84 right now, but basically it's with a mean of this. So for your mean symbol, you're gonna input 65.5, and your standard deviation, you're gonna input 2.9, and then after that, it should be between, your bounds should it be in between 64 and 68. So whatever your lower bound is 64, your upper bound is 68, and you should get an answer for that. You should get a percentage, or not a percentage, but a decimal, which you can convert into a percent. After that, you multiply the percent by the original amount, right? This gives you the percentage of students that are in between these two values, right? So then if you multiply the percentage by the total amount of people, you're going to get the amount of students that are in between these two values. I don't have my calculator right now, so I do not know the answer, but yeah. So this one literally, these types of questions really just kind of get nerfed because you have your TI-84, so yeah. Alright, let's see. F of x has a y-intercept at 0, 2. So f of x has a y-intercept at 0, 2. That's not true. Let's see. As x approaches infinity, f of x approaches infinity. Our value is not approaching infinity. As x approaches -4, f of x approaches infinity. As x approaches -4, f of x approaches infinity. That's true. I mean, that kind of looks true, right? Yeah. As it approaches 4, it's going to get a very high. It's going to become a very, very high value. All right. You can actually enter this into your calculator. Let's just say as x approaches -3.999999999. Right. Notice how you can keep on adding 3 9s to it. I mean, it's going to get to a point where it's going to say undefined because it's so close to 4 that it's undefined, but yeah. If you look at answer choice number 2, f of x has a y-intercept at 0, 2. Well, if f of x is equal to negative log of x plus 4 and then plus 2, well then negative f of x, well, that's just going to be kind of it's going to be this graph, but it's going to be flipped around. So negative f of x is going to look like this. It's just the same thing, but it's flipped around. It does not have a y-intercept at 2. So yeah, we can cross that out. All right. A researcher wants to determine if room darkening shades cause people to sleep longer. Which method of data collection is most appropriate? Cause people... Room darkening shades cause people... This kind of looks like an experiment, right? If you want to determine if these things cause another thing to happen, well, this looks like an experiment. If I were to design an experiment, what I would do is First, what I would do is I would get normal people, right? I would get people to sleep without these shades, all right? So I have this guy. Let's say he sleeps without the shades. And I monitor how much he sleeps. Let's say he sleeps 5 hours. Then I'm going to get a person, and then he's going to wear the shades while sleeping. So he does wear the shades. And then whatever the result is for this one, let's just say if the result for this one is 8 hours, then I know that the shades have an effect, or at least some sort of like a correlation between these two variables. So this looks like an experiment right over here where you have a control, which is basically like the group that is not affected, right? And then you have basically the person doing the experiment, like, yeah, or you know, the person undergoing, our test subject, our lab rats, pretty much. Are the inverse of this function. So remember that this right over here is y is equal to negative 6x plus 1/2. When you're taking the inverse of the function, what you're essentially doing is you're swapping the x and y values. So it's going to be x is equal to negative 6y plus 1/2, right? And then after that, you just solve for y. So if I want to solve for y, what I can do is I can just move this here. So 6y is equal to negative x plus 1/2. Divide this by 6, and then we should get our answer. We get y is equal to negative x plus 1/2 divided by 6. This is the same thing as negative 1 over 6x, and then plus 1 over 12. Because 1/2 divided by 6, that's just going to be 1 over 12. And x divided by, negative x divided by 6, that's going to be negative 1/6x, right? Or negative x over 6. So let me see here. All right, I think this one looks pretty cool. And you can probably check this using graphing as well. Negative 6x plus 1/2. And then we have our inverse, negative 1/6x plus 1 over 12. And then notice how these graphs reflect about the line y equals x. All right, notice how if you take this black graph and you reflect it about this blue graph right over here, you're going to get the red graph, right? Imagine if this reflects about this line, you're going to get this graph right over here, right? So that is kind of the way you kind of visualize this. That is the way you visualize this. Okay. All right. The expression this can be written as what? What can this be written as? Could probably use long division. I want a simple way to do this. X squared plus 12, and then this is divided by x plus 3. Sorry, guys. This is x squared plus 3. Sorry. All right, the function looks like this. Now, if we know, let's just check each of these answer choices. So 10 divided by x squared plus 3. Notice how it has a different graph than what we have originally. And that means that answer choice number 1 can't be correct. You just want to check which one has the same graph as whatever this is, right? Because if this expression can be rewritten as another expression, well, then it has to be equal to that, right? If you want to rewrite the expression, well, you know that has to be equal to the original expression, right? In order for everything to sort of work out. So 1 plus 9 over x squared plus 3, well, it's the same graph. So, boom, there's your answer. All right, that is not number 19. Angle. Which value represents the radian measure of angle theta? The radian measure. Recall that radians is basically another unit for angle measurement, right? Just like how you have degrees, like he did like a 360, right? 360 degrees, you feel what I'm saying? Right, 360 degrees, that's an angle measurement. You also have, that's a measure of, that's a angle measurement. Well, you also have radians. So radians, what you have to know is that each 90 degrees is pi over 2 in terms of radians. So 90 degrees is the same thing as pi over 2 radians. And that means that 1 pi, so this 1 whole pi right over here, that's equal to 180 degrees, right, as you can see. And this also makes sense because if you multiply both this by 2, essentially you get that. But yeah, so notice how whatever angle measure that we have here, whatever angle measure we have right over here, notice how it's in between pi and pi over 2, right? We know that whatever answer that we get, it's going to be in between pi and pi over 2. So let's see. I think 2 would be the correct answer, right? Angle theta, 2, the number 2 is in between pi over 2. If I search up pi over 2, that's equal to 1.5, so it's going to be in between sort of 1.5 and pi, you know, it's 3.141 blah 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 blah, right? So yeah, that is going to be the angle measure of angle theta. They're trying to trick us here because they're trying to they want us to read the question improperly, right? This says radians, but if you thought this said degree measure, you might have thought, oh, this is a obtuse angle, so it has to be number 4 as our answer. But you have to be careful, right? You have to always look at what the question is asking you. The depth of the water is on a phase given by is false. Once again, this question is very nerfed because we have our graphing calculator. Alright. I know these questions, a lot of them, what you can do is you just graph them. And then I'm just going to do x minus 5 and then plus 7. Notice how the maximum height is 12. Alright. So, the depth of the water in feet. So on our x-axis, it's going to be time, and our y-axis is going to be our depth of the water. And notice how the maximum depth of the water is 12 feet, right? 12 feet right here. So we're trying to look for the statement that's false. So this is a true statement, which means it can't be that. The difference in water between high tide and low tide is 14 feet. Low tide, high tide, the difference, that's 10 feet. That looks like 10 feet. That looks like a difference of 10 feet. I don't know about you. But let's just kind of go through all the answer choices. The water depth at 9 a.m. is approximately 11 feet. So remember that this is T hours after midnight, and midnight is 12. So at 9 a.m., that's basically 9 hours. That's 9 hours basically passed. So when x is equal to 9, our y value is approximately 11, which matches up. A low tide occurred at 2 a.m. All right, let's take a look at 2 a.m. This is true. A low tide did occur at 2 a.m. Boom. Number 4 is our answer. All right. A function is defined as this. What is the value of a of 3? Okay, so all you kind of have to do is, well, this is a recursive sequence. So first of all, you have to find what a sub 2 is equal to. And a sub 2 is equal to a sub 2 minus 1. So just a sub 1, right? Because 2 minus 1 is 1. Plus log of 2 plus 1, which is 3, times 2 minus 1, which is just 1. Log base 3 of 1, pretty sure that's just going to be equal to 0. Am I right? Yeah, because 3 to the 0th power is equal to 1. And then a sub 1 is 8. So a sub 2 is also equal to 8. Okay, a sub 2 is also equal to 8. Now let's try to find out what a sub 3 is equal to. A sub 3, that's going to be equal to a sub 3 minus 1, so just a sub 2. You can figure out the amplitude. Remember, yeah, the amplitude. Remember for like the sine graph, right? For the algebra 2 regions, it's very weird because a lot of the times they only give you like the formula like a sine of bx plus c. a lot of times they don't actually do horizontal transformations, like moving it side to side. In this case, they did actually, but yeah, once again, this is basically your midline, right? This is your amplitude, and then after that, this is your horizontal shift. This is telling us that we have shifted the graph. If it's a negative sign, that means we shifted it to the right, the positive side, and then you can find out your period by this, right? 2 pi divided by whatever that is. So, yeah, great job. Great job. All right, anyways, a sub 3, that's going to be equal to a sub 2 plus log of, and that's going to be 3 plus 1, so log of 4, and it's going to be 3 minus 1, which is just 2. Now, 4 to the what power is equal to 2? 4 to the 1/2 power is equal to 2. All right, 4 to the 1/2 power is equal to 2, because this can be rewritten as essentially 4 to the 1 power to the second root. Remember, second root is the same thing as the square root, so the square root of 4 is equal to 2, right? So then, after that, this is 1/2, and we know a sub 2 is equal to 8. 8 plus 1/2 is 8.5, yeah. Of which function has a maximum y value of 4 and a midline of y is equal to 1. Alright, let's take a look at g of x first. So the midline is equal to y is equal to 1, and you can also see this for this other graph. The maximum y value of 4, well, the amplitude is, nah, you see this one. This one, it looks correct, because the maximum value, that's going to be 4 there. And you can also see this graphically, 3 cosine x plus 1, right? It goes down by 3, and the midline is 1, right? The line basically in the middle, right? It's going to be 1, so it's going to be here, right? And notice how you go 3 up and then 3 down. So if you're going 3 up from 1, that means that the maximum value is going to be 4, right? The maximum value is going to be 4. It's going to be number 2. A lot of people, they see this thing and they go, oh, the coefficient is 4, therefore the answer has to be number 4, because my maximum y value is determined by my amplitude. And even though the amplitude does have an effect of, you know, the maximum value, you also have to take into account the midline, right? Essentially what's happening is, I'm just going to draw a random sine graph, but what's essentially happening is the middle of the graph, you can see that's 1, right? The middle of the graph, that's 1. So you're essentially going 4 up, right, and 4 down. Now, what's 4 up from 1? That's 5, right? And what's 4 down from 1? That's -3. So this is in between 5 and -3, which is not what we're looking for. All right, so just because the amplitude is 4 doesn't mean that the maximum is 4. All right, so don't get that confused. Which expression is equivalent to this? This one is just a foiling one, okay? So kind of just FOIL everything out. So this is going to be x times x squared is x to the third. X times all of that is negative x squared yi. That times that is negative xy squared. Now you're going to distribute the y terms. So now we are going to distribute the yi terms. This is going to be plus x squared yi. And then now this is where it gets tricky. This is where a lot of people mess up. So you're going to multiply yi by negative xyi. Now I'm going to do it down here because a lot of times, you know, people, they kind of rush this and, you know, they get it wrong. So notice how y times y creates y squared. The x is going to be left alone. The negative sign, let's just say it stays there, and I multiplied by I is equal to I squared. I to the second power is equal to -1. So essentially this negative cancels out with this negative, and you just get xy squared. And then you're going to have yi times that, which is negative y to the third I. Okay, let's see if we can simplify things. We have a minus yi here, and we have a plus yi here. We can cancel them out. Negative xy, positive xy, they cancel out. So you're essentially going to be left with x squared x squared right over here, and then that's going to be negative y to the third I. X squared, x to the third power, sorry, x to the third power minus y to the third I. Alright. The growth of a $500 investment can be modeled by this function. In terms of monthly rate of growth, the value of the investment can best be approximated by what? Okay, so t represents the time in years, alright? T represents our time in years, and this is our original function, alright? T is in years. How many months are there in a year? There's 12 months in a year, right? So if we want the monthly growth, well, all we have to do is we can rewrite this equation as 12t over t, 12, right? Notice how the 12s cancel out, so it's the same thing as we had before. Now what I'm going to do is I'm going to use my exponent properties, and I'm going to say, okay, this is equal to 500 times 1.03, and then this is going to be to the this is going to be the 1/12, and then all of this is going to be to the 12th power. Oh, okay. So right, the thing about problem 24, the thing about problem 24 is that they're trying to look for the monthly growth rate, right? But the problem is that, like, we still have to make our equations equal, right? This is the yearly growth rate, and we want to find out the monthly growth rate. But the monthly growth rate, we have to make, like, the equations equal to each other, right? We want to make sure that everything is equal to each other. So in this case, right, we're going to have 500 times 1.03 to the t power. And then after that, you're going to have 500 times 1.03 to the 12t over 12 power, because the 12s just cancel out. So this is the same thing as what we had before. And then now you're going to have 500 times 1.03 to the 1/12 power, and then this is going to be to the 12t power. So if you have 1.03 to the 1/12 power, this is going to be 1.002. This is 500 times 1.002 to the 12th power. So then that's going to be our answer. So in this case, 0.042 to 12th power. Right? If you're trying to find the monthly growth rate, then it's going to have 1/12 of the yearly growth rate, which is why I rearranged the equation like this. All right. Let's see. Oh, we're pretty much done with all the multiple choice. So yeah, that's all, guys. Thank you for tuning in, and I'm sorry to my friend Blackest if everything was a little confusing. I'm sorry, guys. I'm kind of in a time crunch. It's currently 10:30 p.m. I have to go to sleep. I'm sorry, guys. So